Hello all, welcome to Pamita AI World. My name is Pamita Singh Kandari and you are watching my YouTube channel Pamita AI World. So all the students, in my previous video I taught you about covariance and correlation, and in previous video I also, in the last of the video I told you that I will give you the example of real time example of covariance and correlation, where we use these two terms in our real time world. Fine. Where companies used these covariance and correlation in our day to day life for their own purpose. But before telling you the example of covariance and correlation, I would tell you about the difference between standard deviation and variance. Why I am saying so? Now in between of covariance correlation, why I am teaching you standard deviation and variance? It is because once you would understand what is standard deviation and what is variance, then only easily you can understand the real time example of covariance and correlation, because these two terms of standard deviation and variance are interrelated to covariance and correlation. So let's get started. First we would know that what is standard deviation and what is variance. I will try to teach you in a very simple way so that you can understand, who are non technical, who students who are from non technical background, they too can easily understand what I am trying to say here. So what is standard deviation? Standard deviation and variance. I will teach, although I have taught you about the variance in my one video was full on the topic of variance, but again I am teaching you variance here because standard deviation and variance have a small little difference to each other. Many students get confused between standard and variance when they start to applying these two terms in their AI model or data science model, or we can say in real time example of a statistic also. So standard deviation and variance, we would check it here, what is standard deviation and what is variance. So first we will see that these two terms are measures of, these standard deviation variance are both measure both measures how spread out of a set of data is from mean. Fine. Standard deviation and variance both measure how spread out of a set of data is from mean. What does that mean? What exactly I am trying to say here? Let's suppose we see the graph in data science like this. Like this. Okay, this type of data. Fine. uh, you, all the students who are from technical background, they would understand it easily what I am drawing here, but students who are from non technical background and they are learning data science or artificial intelligence, machine learning, they would find it difficult that what I am drawing here, but I will try to teach you in a very simplest way. Let's suppose you, all the students, have seen this curve which we call bell shaped curve. Fine. So somewhere uh, it is like mean. Mean means average. average. Fine, average. So standard deviation and variance, these two terms tell that, suppose here data is here, data one data set is here in this paragraph from mean. Fine, and another paragraph is here, and this is the mean we have calculated, mean or average, mean or average, and that data set is near somewhere here, closer to the mean. So now you can see that some data is closer to the mean, this data set is very near to the mean. Fine, and this data set is farther from the mean, farther from the mean. Here is the distance is this, but here it is almost near to the mean. So these two things are told by standard deviation and variance. Fine. Now what you would say, what you student would ask, that when these two terms are telling that which data set is farther from the mean and which data set is near to the mean, then why we are using two terms, standard deviation, variance? Why we are using two terms? We can use one term, but here is the little difference between these two terms also. Although they tell about the distance, how much spread, both measures how spread out of a set of data is from the mean. Fine. So there is a little difference between them. So what is the difference between standard deviation and variance? Look, variance variance is average of the squared differences between each data point and the mean. Fine. What does that mean? Average of the squared difference between each data point and the mean is called variance. Fine. And what does standard deviation mean? Standard deviation means the square root of variance. Square root of variance Look, what does that mean? Variance, average of the squared difference between each data point and the mean. Let's suppose I draw some dots here, but what if I'll say that this is the bell-shaped curve and this is the mean, and here are some numbers. Data sets are in numbers, like 1, 2, 4, 6, 7. Fine. 8. So these are in numbers. So average of the squared difference between each data point and the mean. So variance is nothing but, I'll give you the example of this thing, that these data points, we will do the square of these data points, like 6 square, 2 square, 1 square, and after squaring these data points, we will take the average of these data points, fine, and after taking the average we will see that how much farthest these data points from the mean, that is called variance, fine. And standard deviation is the quite simple, that it is the square root of variance. What does that mean? If we calculate the variance, then on the basis of variance we can easily calculate the standard deviation, fine. So I'll give you one practical example also of variance and standard deviation. Standard deviation is the spread out, standard deviation SD is the spread of group of numbers from the mean, while on the other hand variance measures the average degree to which each point difference from the mean. Look what I am trying to say here. Standard deviation is the spread of group of numbers from the mean, while on the other hand variance measures the average degree to which each point difference from the mean. Standard deviation just simply tell that how much farthest these data points are from mean. But variance measures the average degree. Average degree means variance square these numbers, fine. Average variance, what variance does, they square these numbers, and after squaring these numbers, like 2 ka whole square is 4, 6 ka whole square is 36, fine. So what happens in variance, they calculate the average of these squares of these data points, how much farthest they are from them, and then after that from that square of these points, how much farthest these square degree is from the mean, that is called variance, fine. Why under variance these data sets are squared? Just think that why they are squaring these data points, because in real time example, standard deviation or variance is used in stock market or you can say trading market. So portfolio manager or the stock traders, when they try to know that the shares or stocks they have bought for their customers or for their own sake, whether they are risky for whether these stocks are risky for them or they are profitable or not profitable. For calculating these things they use variance, fine. For calculating these things they use variance, and that is why they are squaring these data sets also, fine. So these two terms are used in stock market and trading by portfolio managers or stock market managers, fine. So let's take one example here, what I am trying to say here. I'll give you one example also, calculating example. Let's suppose I have given you one example here. These are the data sets of the number. Let's suppose here these numbers are data sets are 4, 3, 4, 18, 12, 2, 26. Fine. This is the data sets we have, the traders have with them. What first we'll do, portfolio managers, what will they do? They would first calculate mean here, mean of this data sets. So what is the mean of the data sets, mean or average of the data sets? It is very easy to calculate. 4 plus 34 plus 18 plus 12 plus 2 plus 26. And how many numbers are there? 1, 2, sorry, 4, 34, 18, 12 to 26. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So there are 6 numbers. Fine. So after adding them, 6, 2, 8, 9, 10, 18, 4, 22, 22, 4, 22, 4, 2, 4, 5, 6, 6, 2, 3, 4, 5, 6, 7. So here mean average came 16. Fine. After adding these numbers and dividing these numbers by how many numbers are there, like 1, 2, 3, 4, 5, 6. So divided that 6, we adding addition come 96 divided by 6, then average came 16. Fine. So this is the average we came. Now to calculate variance, what variance I told you, what variance means? Variance I told you, what does that mean? Average of the square difference. Average, variance is average of the square difference between each data point. Squared difference. So squared difference means first we have to calculate the square of these number also for calculating variance. Fine. So what is the square of this number? Square difference between each data point. So subtract mean from each number. So here 4 minus 16 का whole square. Why we are subtracting 4 minus 16? Because it is saying squared difference. Difference means subtraction. Fine. Average. Then average, first we will calculate the square difference. Then after calculating that square difference, we will take the average. We will calculate the average of that square difference. And what is the square difference here of this number? It would come 16 minus 4, 12, 12 2 ja ka whole square. Look, it would come minus 12. 4 minus 16 is minus 12, and the square of minus 12 is 144. Fine. Again we will see 34 minus mean 16 ka whole square. How much it would come? 6, 7, 8, 9, 10, 11, 12, 13, 14, 8 and 2 1 ja. इसका square would come 324. Likewise all these numbers would come 18 minus 16 का whole square would be 4. Fine, it would come 4. And 12 minus 16 whole square would come how much? 16. 2 minus 16 whole square would come 196. 196. And 26 minus 16 whole square would come 100. Fine. Now what we will do? We will do average or mean of these squared values to get the variance. Fine. Why we are doing that? Because it is saying average of the squared difference between each data point. So square difference we have calculated, that is the square difference 144, 324, 16, 196, 100. Now what we will do, we'll take the average of these squared values. So what is the average of these squared values? How we'll calculate that average? It is quite simple. You know how we calculate average? It is 144 plus 324 plus 4 plus 16 plus 196 plus 100 divided by how much? How many? 1, 2, 3, 4, 5, 6. So what average would come? It would come 6, 6, 12, 4, 16, 64. It would come somewhere near 130. 130 it would come. 130. 130.67. Fine. 130.67 average would come. Fine. For that square difference, average would come 130.67. So what this value came? This is called population variance. Population variance. Now in my previous video, if you are old students who are going through my all the videos, fine, if you are my regular students, you would know I have told you about the how we will calculate population variance and sample variance. And for whenever we calculate sample from population, I gave you one formula also, that to calculate any type of sample from from population, let's suppose we will subtract -1. Let's suppose if population is n, so to calculate sample from that population, we will do n-1. Fine. This is the thing I have told you in my previous video. If you will go through my previous video of population and sample videos, I gave you one example also. So to calculate sample variance, here, I hope it is visible to you. Sample variance, what we will do, same thing we'll do. 144 plus 324 plus 4 plus 16 plus 196 plus 100 divided by n-1. Here n is 6, but here what we will do, n minus 1, or we can say 6, 5, because 6 minus 1 is 5. So what sample variance would come after addition? After doing that, sample variance would come. Let's calculate it. 6, 6, 12 for 16, 16 for 20, 24, 4, 0, 9, 10, 11, 12, 13, 14, 15, 16, 1, 1, 2, 3, 4, 5, 6, 7, 7, 7, 5, 5 divided by 5. So it would come near to 150. Fine. It would come I'll write in different color, 156.8. It would come like this. Fine. So we have calculated variance. What population variance and sample variance. Now what standard deviation is? So variances we have calculated based on the definition. I have calculated these terms, all the data sets based on the definition I taught you. I have calculated variance. So in standard what standard deviation come? What is the standard deviation in this whole example? Standard deviation. What is the definition I taught you about the standard deviation? I gave you that the square root of variance is called standard deviation. The square root of variance is called standard deviation. So after we have calculated population variance 130.67 and sample variance is 156.8. So based on the definition of standard deviation, we can say that standard deviation is nothing but square root of variance. So we'll simply calculate the square root of variance, that is 130.67. So square root of 130.67 is how much it would be? It would be around 12 12 ja 144, 11 11 ja 122. 11 ja 122. Okay, I'll tell you, if you are new by two students who are not from mathematical backgrounds, I'll teach you how we calculate square root in a very faster way. Look, here is 130. 130 is near to what? If we'll double the number of 12, 12 12 ja 144. Fine. So 144 is larger than 130. We have to see where the less of will take one number less from 12. So what is 11? 11 11 11 ja 11 1 ja 11 11 1 ja 11 and 1 121 is it would come 121. Fine. 11 ja 11. Fine. So this 130 value is coming under 121 to 144. Fine. This is coming somewhere 130 is coming here. So what we will take here? We'll take 11. Fine. 11 point, and 0.67 we will consider is somewhere is come 11.43. Fine. Or we can say 11. We calculate square root like this. Fine. So in a faster way, if in exam you don't have much time to calculate, fine, so by seeing 11 you can tick 11 also, or you can consider 0.43 lesser on, like you cannot you can neglect 0.43. So somewhere 11.43 would come. So what is this 11.43? It is standard deviation. Fine. So standard deviation of population variance. Fine. And what about sample standard deviation? Because we have calculated sample variance also. So for that, standard deviation would be somewhere around 156.8. It would be around 12.52. Right. So this would come. So this is the thing I taught you about the standard deviation and variance. Now the question arises, where in real time example where standard deviation and variance are used. Look, in real time example, I already told you in between of that video, standard deviation and variance are very oftenly used by traders, stock market, portfolio managers, analysts, all the analysts who are investing their money or their investment in their we can say mutual funds or stock market shares trading. They use standard deviation and variance to to check the risk about um, volatile nature of stocks in day-to-day life, because stock values get changed in seconds or in minutes. So what they do, they just apply this standard deviation and variance, and based on this standard deviation and variance, look how much farthest their stocks are from the mean. If the stocks are nearer to the mean, fine. If the stocks they invested are nearer to the mean, it means the risk is less, so it would be beneficial for stock traders to invest their money in stock market. If that data sets or data points or their stocks are farther from the mean, it means that their stock the money they are investing, they may get um, may get in loss in stock markets. So this is how variance and standard deviation are used by traders. So this is for all today. For today's video, all the students, I taught you about standard deviation and variance. And now we'll jump to the covariance and correlation. By learning this word covariance, you would understand that variance is somewhere related to covariance. So in my last video I taught you about the covariance and correlation. Now I'll give you the example of covariance and correlation. Now you can easily relate these two terms. Fine. So this is for all for today's video. And if you like my video, please like and subscribe. Thanks for keep watching my video, and thank you for trusting Pamita AI World. Keep watching, keep learning. Happy learning. Thanks a lot. Namaste.